Yes.
There we go. Now we're recording. Good. Sorry about that. So, for those of you may have heard that I figured out my technical difficulty, and it's the funny thing is today somebody else told me that they had the same technical difficulty with Zoom. Turns out Zoom has two different clouds. I didn't know that. And I was trying to connect to the wrong Zoom cloud. Funny thing is, it was let me in as a guest, but it wouldn't let me in as a host. So be careful with that. Zoom has what's called the government cloud, which is one of their more secure areas. And I just happened to have been on a meeting from work that was on the government cloud. And after I took the system down, it kept me connected to that rather than going back to the normal cloud, I guess you call it, So if you ever have a situation where you can't connect, and this was only through the app, the web worked fine, okay? But if you go through the app, there at the top where it says Zoom, there's a little caret next to it. Hit the drop down and you'll have a list of the Zoom networks you could get on. If it's attached to Gov, attach it to just the one that just says wichitastate.org, wichitastate.zoom.org, I think it is, or something like that. Okay. And that should get you back to normal. So did that and everything seemed to work fine. So, well, and the other thing I have to apologize for, we just noticed this, is that the Thursday sessions for some reason were scheduled at 8:30 in the morning. Okay, even though in the heading it says the right time and everything. I think a lot of you figured it out. I just sent an email to everybody. Hopefully they caught it that we are meeting right now. I didn't realize that on the recurring meetings, I didn't have to do two of them. I could do one that does both Tuesday and Thursday together. Mostly, when you use Outlook, you got to do separate ones when you do meeting notices like that. So I will probably delete the one that we're using right now after we're done with this tonight. And then I'll update that first one and I'll just get rid of that other link. We'll only have the one that you have to get on then all the time. And I'll send out emails to everybody, making sure they know that. And I'll fix what's posted on Blackboard. So we have the one way of getting into these sessions when we finally get going here. All right. Before I get going, are there any really quick questions based on anything that happened before about the logistics of the class or anything like that? Okay. If not, we'll get started here. And I'm going to start off by asking you all a question. All right. You're all undergraduate industrial engineering students. Some of you are probably already working as IEs, or you're interns, or you've got jobs lined up, or you're working some other type of job, but you want to be an industrial engineer eventually here. What do we build? What are we about? What is, civil? I'm a civil engineering. I was a civil engineer as a bachelor student. Okay. Truthfully, I've been almost every engineer that you could think of. All right. But civil engineering, when you say that, people immediately think about dams and roads and bridges. You say mechanical engineering, people think about machines, equipment, automobiles even could be in there, airplanes, mechanical things. And you say electrical engineering or electronic engineering, people think of, circuits and computers, and, machinery for computation. When people ask you what an industrial engineer is, being an industrial engineer is about, what do you tell them? Feel free, anybody jump in.
I normally say like systems and process design.
You're further ahead than most people if you're saying that, okay? And I think a lot of that you're probably influenced by the fact that this is an information systems class, okay? Because the reason I'm asking you, okay, it's kind of funny. Every year the Institute of Industrial and Systems Engineers sponsors a YouTube video contest where they want student chapters to make a video about industrial engineering, and it is amazing to me that when they do that, they always say, the first thing they'll say is, industrial engineering, we're about process improvement. Okay. And I mean, I'll just hear this over and over. We're about process improvement. We're about process improvement. You know what? And here's something I always say. Do you think all the other engineering disciplines aren't about process improvement or aren't about improving things? Everything we do is, and whatever kind of engineer or scientist or mathematician or anything that you're doing in the STEMs, it's about improving something, right? And if you want to call it process improvement, that's fine. I mean, it's there. Civil engineers have processes they try to improve. Product improvement, that's another thing. It always breaks my heart when I hear that, because I think you've missed what we're really about here. Granted, that's an important thing that we do, but that's not what we build. We don't build process improvement. The thing, and I'm going to tell you right up front, the thing that really disappoints me then is they usually will interview the head of the department or some faculty member, and they'll say the same thing. We're about process improvement. We get involved in everything because we're interdisciplinary. No, we're not. We have a discipline. Okay. Does it touch a lot of other disciplines? You bet it does. We're kind of at the center of the storm. Yeah, you are absolutely right, Kate. It is about systems. We design and build systems. More to the point, we're about system integration. All right. All those things that the other engineering disciplines do, we make them work together. Okay. You don't have a bridge building thing without an industrial engineer on it. You don't build airplanes without industrial engineers. You don't run a hospital without industrial engineers. We have to be very mindful of a lot of disciplines when we do our work. But yet we have to understand the core knowledge of what it means to design, build, test, deploy, implement, whatever you want to call it, sustain, service systems. Okay. So then it leads to the philosophical question, what's a system? You'll hear, well, systems are collections of highly integrated processes. Really? Well, what's a sub-process? What's a subsystem? What's a supersystem? You know what? I'm not here to worry about that kind of junk. That's made up for people who are putting ontological taxonomies together and trying to figure out hierarchies of things. Okay, we're not going to do that in this class. Okay, we are going to take it from the perspective that we are in this class about building systems, designing, building, implementing systems that service data. Okay. Aziz and I were just talking about this. The history of industrial engineering really is centered around material. Okay, you think about our production lines that we came up with in the 20s and 30s. All the things that Frederick Taylor and the Gilbreths did on time management and standardization and work planning and all that. It was always about material. We were putting bricks together. We're assembling an automobile. It was about taking something physical and usually mapping it up with something else that was physical. Somewhere along the lines, we realized, though, that it isn't just about that product and the physical manifestation of the product and the tools and the factories and all that. It's also about the energy that goes into play in that, that things have to move and all that, So there's energy involved in this. So our two entities have always been historically material things and energy. Okay. Starting about 1970, data entered the picture. And it entered in the form of what we call databases. Now, we've always dealt with data, sure. We've always done some level of analysis. But you know what? It really wasn't until the 1970s that industrial engineering started moving away from an artisan practice to a scientific practice. And it was really because of the operations research guys, okay, who could have really said they had their own discipline, and sometimes they still do. But it's for some reason they were very married to industrial engineering. And so that became part of our bailiwick, okay? Starting around the year 2000, data became the leading entity for us. There are three types of entities: material, entity, data. All those other things that are out there fall into one of those categories somehow. That's the top of the ladder. That's the top of the hierarchy. Okay. Those three things, whether they have all in common, they can all be processed. Material can be processed, energy can be processed, data can be processed. Now, one thing I want to be careful of here, okay? Systems is obviously in the name of this class. The other part is information. Well, shouldn't this be data systems then? Yeah, technically they should be, but we talk about information. Okay, we almost use data and information, in the same vernacular. We use them synonymously, but they're not really. So I'm going to start tonight. I'm going to give you, because we had problems last time, I'm going to give you an abbreviated hybrid version of the first night and the second night, just hitting on the main points. And I've already sent you an email saying I'd like you to look at the video from last semester to get the stuff I'm not going to cover tonight, and I'll talk about a little bit of that toward the end. Okay. But also, even in like the seminars that I post, there's a lot more information that I'm not going to cover tonight, and it isn't in that video. All right, it's really there for your something for you to digest a little bit. Okay, won't ever test you over that stuff. Okay, but it just kind of gives any of you who really want to delve into a little bit of the history of this, and especially the organization of the whole thing, it might be worth your while to go and just look through that. But you don't have to memorize anything. I'm going to point out what I consider to be the big stuff. So I'm going to share my screen right now, and we'll get going here I'm bringing some of this stuff up. It is this. I want to first do these frequently thought question part, and I'm going to zip through this really quick, but it does have to do with what I was just talking about, some of it. Okay. What's this course about? And I'm sorry, I'm going to have to, again, shrink you down. Well, no, I think I probably leave you here for a little bit. Okay, I'm seeing if got a few of you on the side here. Aziz, Cade, Caden, Sean, Carlos, I'm seeing you guys right now, so don't fall asleep, because this gets recorded and you see the guy sleeping. What's this course about? It's about information. Okay, it's really about putting data into context. Okay, that's the definition of information: data in context. All right, I say there's never any math in here. This is the closest we're ever going to see. Information is a function of data and knowledge, but knowledge in time. In other words, knowledge at a certain point in time, or maybe in a certain frame of time. All right. Okay. When I say data in context, knowledge is what gives us context to our data. If I just start saying dog, 3, Toledo, you have no idea what I'm talking about. All right. If I talk about the fact that I had a pet when I lived in Ohio and he died at the age of 3, now you got context, huh? Something like that, So, I used to always do that. I used to put numbers on the board and say, does this mean anything to anybody? And everybody, But then I put team names next to it: the Cubs, the Reds, the Pirates, and all that. And people realize, oh, that was standings that day in the National League Central Division. It had context. I put the team names on, and people, they didn't know the percentages necessarily. They kind of knew the place because of the number of wins that were there, but they knew the context. It was standings in baseball because they recognized some teams that were there. Now people who didn't understand U.S. sports or weren't baseball fans, context might not mean it. So you have to state the context. You have to put it there. All right. Most of what we're going to be doing here this semester has to do with the context. Okay. Yes, we're going to definitely use data, but what we're going to do is we're going to put that data in the context. And when we put the data in context and we can automate that a bit, we get an information system out of it. So that's what we're about. We're about representing and structuring our data. We're about presenting and interacting with the data. And it's about visualizing and communicating the data. That's the things that this course is really about. So People always ask me, why is this a required course? If you heard Aziz and I talking, and Aziz said it, this is one of the most important classes you're going to take in your career. All right. There isn't an industrial engineer out there these days that doesn't deal with data on some level. And the ones who get really good at it are in real demand, and they get really good jobs. All right. This is probably in fact, it may even be what I consider the most fundamental course if you ultimately want to become a data scientist. All right. It's funny. I've done AI, I've done OR, I've done incredibly advanced things with neural networks and all that. Aziz was in my neural net class. He'll tell you they're no simple thing. But you know what? If you take this class, those things make a lot more sense to you, because even after we get done with all this, you never build another relational database management system, which is what we're going to be building in this classes. You will understand about object orientation. You will understand about relational methods. You will understand about visual programming. You will understand about rapid prototyping. You will understand about connectivity. Okay. All that stuff is going to come into play. And a lot of times you're going to do it and not even realize you did it until after you're done. And I tell you did it. Okay. With the method that we've developed over the years, we have removed you having to learn a lot of theory here in order to be successful. But at the same time, you're going to get exposed to it and you'll understand it better after you have actually done it. So I always say, yeah, you got to take this because ABET requires it, that you take it. Okay. But the truth is we would pretty much insist that you take this class anyway. Okay. Industrial engineers find ways to eliminate wastefulness in production processes. They devise efficient systems that integrate workers, machines, material, information, energy to make a product or provide a service. And that was from the Bureau of Labor Statistics, Occupational Outlook Handbook. They know everything. Okay. And they know what we are. And look in that thing. It says information and it says systems. So you're going to get the best of two worlds really are coming together here. Okay. We'll learn a little bit about information tonight. We'll learn about systems. And then starting next Tuesday, we're going to start learning about information systems. So systems of information are part of an overall production process. By the way, industrial engineering, that's actually a terminology that's starting to go away. You go to a lot of countries, we're called production engineers now. Now I think that almost sounds a little too manufacturing oriented, because I'll tell you the truth. Next to manufacturing, the second biggest area for industrial engineers is healthcare. Okay. What do you think the third is? Anybody want to take a guess? See, I thought it would be construction, but it's not.
Data analytics.
Well, analytics is a thing that we do in all those areas. Okay. It's not, yeah, I get that you're saying it's a role that we play and all that. But I'm talking about an industry. What other industry are we highly associated with now?
Supply chain.
Supply chain, but again, that tends to be either in a service industry or a technical manufacturing area or something like that. It's part of something. I'm talking about a full industry. Supply chain truthfully isn't an industry. It's a layer of architecture within an enterprise.
Maybe too general.
Industry.
What's that?
What about the airline industry?
Well, and again, airline. Okay, so it's services. I guess we could call it services. Yeah, and you're probably right. That is probably the third biggest one. I didn't even think of that one too much. Yeah, but where I was going with this, believe it or not, one of the industries that we are huge in right now is sports and gaming. Why? Because I said we have suddenly become the data architects of the world. And after Moneyball, every sports team on the planet decided that their metrics weren't right, that the way that they were running their teams didn't make sense. I am an absolute nut about the Chicago Cubs. Okay. When they won the World Series, I only had two greater moments in my life: when I got married and when I had my daughters were born. That's it. Okay. The Cubs won the World Series. That was it for me. Okay. And I can tell you, one of the things that finally helped them win the World Series is they changed their notion of what it meant to have a team, and I'm hurting right now because they just got rid of three guys who really loved, but you know what? The numbers support them. that they really needed to get rid of those 3 guys so they could build another winning organization. At least they believe that now. Okay. Guess what? It's industrial engineers that are doing those things. It's not statisticians. Yeah, some of them are, we have a good statistical background, but they realize it's more than just crunching numbers. It's looking for patterns in those numbers, mining new situation, new knowledge out of it. But it does start with organizing the data. And believe it or not, that is the thing that most companies right now are throwing a lot of their resources behind. Data is the new fuel that drives our economy. It is the thing that will either make or break most of the major companies on this planet, how well they deal with their data. And right now, data is getting produced quicker and in greater volumes than it ever has before. So much that if we all did it, just all of us, I mean, I don't just mean industrial engineers, everybody who's employed, if that's all we did 24 hours a day, we wouldn't be able to keep up. Okay, I'm going to throw an interesting fact at you. The amount of information in this world doubles every 18 months. If that doesn't scare the heck out of you, it will by the end of this semester. All right. Think about that. Anything that's ever been done, from people putting paintings on caves till right now, all the pictures, all the video, all the alphanumeric information, all the things that we call data will double in just the next 18 months. There are more photographs taken in the next minute than were taken in the first 100 years of photography. Isn't that nuts? Who's taking care of it all? Think of the storage that's needed for all that. Think about what you do, how much effort it takes to relate the stuff. And that's what we're going to be doing. We're going to figure out ways to relate massive amounts of data using very general techniques to do it. Why do you need to take this seriously? The opportunities that are out there right now. It's amazing. I told you half the 30 biggest, most in demand jobs, highest paying jobs, have something to do with information systems. The truth is, I think there's only 1 or 2 on the whole list that doesn't have something to do with computation. Okay. And if you're doing computation, 99.999% of the time, you're dealing with data. So we take this very seriously for that reason. And the fact that, at least in John Huffman's opinion, industrial systems engineers, which is what we're really starting to be called now, make the best applications-oriented data scientists and enterprise architects. I know those phrases don't mean a whole lot to you right now. I will talk about these things a little bit more as we go through the semester. There's some of this is in the videos that are coming down the line anyway, all right? But we are being called on not only to do the analytics stuff, but also to architect the enterprises and where analytics could help us in the enterprise. It's a huge job. It takes a lot of technical skill. It also takes a lot of business skill to do this. And that's one of the things that we as IEs basically get that type of training. Okay, I'm going to go on here because the other part of this I want to talk about is survival.
Professor, I have a question.
Go ahead.
So when you talk about architecture, are you talking about like designing the actual software or using the software? I
am talking about applications, data, processes, infrastructure, which could include both hardware and a network capability and the security behind it. And I'm also talking about the strategy behind it. Okay. Those are what we call the layers of enterprise architecture. By the way, architecture is one of those words that can be used very narrowly or very broadly. And I tend to use it broadly. Okay. It's not about just architecting software. Okay. It's about architecting everything that has to do with the information system. In fact, I'll talk about that on the slide here pretty quick. Okay. But the other part of this I want to impress on you is survival. Okay. I think I said this last time that we in the universities, we are in a transition period where we're still teaching you the older methods for doing industrial engineering stuff. But we also know that a lot of those are going away and they're being automated. All right. Not many people go out in factories and hold a stopwatch up anymore. You know, the machines themselves know when they were turned on and turned off, and they can generate a report. You know, so traditional industrial engineering is I hate to say, going by the wayside. I'm not trying to tell you that what we taught you isn't going to be practical anymore. It will be, because somebody is going to have to turn that old mindset into a new mindset. So while it may be difficult for people who are purely just traditional industrial engineers in the future to find easy employment, it's going to be really easy for people who are doing the automation, and we do the automation. So, you know, KK and I have actually talked about it. Dr. KK and I have talked about it several times, you know, that maybe we need to have two flavors of the bachelor's degree, you know. Now, there are still a lot of smaller manufacturers and smaller service firms that will need industrial engineers and all they need is traditional industrial engineers, simply because their processes usually aren't that deep. They aren't that complex, or they can't afford to do it. Okay. And that's one of the things that's kind of scary, because the most, you know, it's interesting. People I know who have absolutely no background in industrial engineering, but they are in leadership positions in their company, tell me all the time, we got to do this or we're not going to survive. You know, they know it. So, and the cool thing is, we're the kind of guys that can help them. So there is a lot of opportunity for us, and you're seeing every day more and more demand for our field. You know, I've been, like I said, I've been a lot of different engineering, and I really didn't take industrial engineering degrees because I wanted to be an industrial engineer. I was always doing the fringe stuff, the AI and all that, which are that's not mainstream industrial engineering. At least it wasn't when I took it. You know, it's starting to become more and more mainstream. OR, I don't think anybody would argue that it's mainstream industrial engineering, except for the OR guys who argue that they have their own discipline. It really isn't industrial engineering, you know. But the fact of the matter is, we have become a very different thing than what we were just a few decades ago. A few decades ago, you became an industrial engineer if you couldn't make it be in any other kind of engineer. All right. We were the lowest paid engineers. We were the ones that were considered the least technical. Now we are really up there. If we're not at the top, we're really close to it. Okay. As far as in demand and technical. All right. There's things in the chemical industry that are probably a little bit more involved than what we are, you know, but for the most part, the amount of effort that's needed, we're definitely in the highest demand now. And because of that, we're starting to become some of the highest paid engineers in the field. All right. A little bit about the background and history. Okay. Especially of information systems. Okay. Because you'll hear that other departments have things like information systems, and they do. Truthfully, prior to the year 2007, it was kind of the same for all of us. You know, it was, yeah, believe it or not, the kind of stuff I'm talking about right now, that's all the class was about. People memorized lists of stuff. They learned how to do data flow diagrams. Okay. Around 2007, an interesting thing happened. Computer science, and specifically industrial engineering, decided that information systems was really about the data. And what we needed to do was interject database management into this. And in fact, it really is what we became. All right. In 2007, 2011, what we saw is the relational model and the normalization of data become at the center of the center of the storm. Most of our companies were hurting really bad because their data was just terribly structured. And they said, we need to do that. And this is an industrial level activity in our company. We're not expecting just the IT organizations to do it. We're not expecting people with with a computer science degree to do it. We want engineers to do this on a regular basis as part of their job. And so we, thinking ahead, adopted that practice. And that's about when I came into this. And that's when we switched to a real, what I call an object-oriented approach to doing this. If you don't know what that means, you will in the next couple of weeks, okay? In 2012 then, now the interesting thing is the other departments, they kept doing it the traditional way, all right? We were pretty much on our own. We were pretty much the ones who were starting to develop data sciences at Wichita State. Well, then around 2012, the other ones realized we were getting ahead of them. I think, okay, this is just me talking, okay? But it was me. I was doing it, okay? So we adopted what's called the entity relationship object, or sometimes it's called the entity relationship attribute approach to building information systems, so that you didn't have to be great at using C or COBOL or C++ or Python or anything like that to be good at this. We were going to actually give you the tools to allow you to basically design and build systems without much coding. In fact, in this case, you're going to see very little that looks like coding in this class, okay? From 2013 to the present, it was really the years that I developed the BAL and our method for doing the fundamental components of an information system, so that you didn't walk out of here thinking you just took a class in Access, that you walked out of here knowing that you really learned information systems, okay? We are going to use Access and databases basically to explore the objects that are about information systems. That's what this class is really going to do for you, okay? People, and I always have to address the programming, okay? Is this class about programming, okay? I used to say, no, you know what, kinda, but it's not like programming like you've been exposed to, okay? You're not going to write gobs and gobs of commands, okay? Instead, you're going to do, some people call it software by pictures. It's really visual programming, if you will. Well, you'll lay things out on the screen. It's going to be like connecting Legos, but the Legos could take on different features depending on what you want to do with them, okay? And it's all very parametric in that you specify the value for certain parameters and the thing becomes that thing, all right? We're going to do almost everything in this class that way. It's not until the very end that we actually do some things that are a little bit different, a little bit that will remind you a little bit more about building logic, okay? But until then, the logic is kind of built into everything we do. So I've gone through this already. I'm not going to do it again. We're going to use Access, and again, 2016. By the way, has anybody downloaded it from Azure yet? The Azure site.
Yeah, I have.
And any problems?
I did not run into any.
Excellent. Good to know. Good to know. Good to know.
When
All
you
right.
found the link to Azure, do you have to download it through there? Or does the link bring you right to Access?
No, it downloads Access to your machine.
Okay.
That's a software store. In fact, you have everything that's out there. You could download it. It's free to you. Take advantage of it. I looked at some of that stuff and I go, holy cow. They are literally giving you $100,000 worth of software there if you want it, you know. But yeah, it's free. You're actually, I think, really downloading Microsoft Office, if I'm right. No, it's Access. It's Access to 16, but it's the 64-bit version of it. Okay, be careful about that. Okay, if you need 32, you know, somebody told me it's out there somewhere, but I haven't been able to find it. You know, we'll have to explore if you need 32-bit. Okay, and again, even though 16 is the preferred, you know, you get by with 10, 13, and 16 also, okay? And then the baseline object library, which I'm not even going to give that whole thing to you until the very end of class, okay? Instead, I'm going to give you work files, and the parts of the BAL that you need for those work files will be in there. The baseline objects that you need to do your assignments, to do your projects will be in there already. You won't have to mess with the whole thing, all right? And again, I already said that there is no required text because I built a workbook for you, okay? And truthfully, people who've seen it, who've taught this class and teach it at other universities have told me, oh, John, you need to get that published. That's excellent, you know? I've actually, this class has actually been the subject of several presentations that have gone on at major conferences about how to teach information systems. And our method And it's Larry Whitman. And guys, I don't know, think you know Larry Whitman. He was here for a long time. He was one of the better professors I've known in my life. I ran into him at ISC, and he came to my presentation after. He said, John, that is just about the smartest thing I've ever seen anybody do. For, he goes, it's amazing, because he knows, guys, I'm going to tell you right now, you are only doing about half the work that people did back in the year 2007, 2008 when I taught this class. Okay, when it was raw access, you had to do everything. Okay, now you're only going to have to do those things that really help you understand the objects that are involved in building information systems. You don't have to worry about the database. Except, I mean, I want you to worry about the data, obviously, and relationships, but building the mechanisms to make data actionable, you're not going to have to worry about that at all. Okay. I had to sign in, and I realized some of these are dated. Now that we're online, I don't think this applies anymore. Do you need a laptop? No, but you need something to utilize access. If you don't have it yourself, you're going to have to run up to the university to use it. Okay. One thing I do recommend, though, is that you have the ability to have an access screen up and have another screen so you can look at the workbook or a video, one of the tutorial videos while you're doing your work. Okay, so if you got two screens on your computer, that will help. The other thing you could do is have a laptop and a computer next to you and do it that way. Or, a couple of my students last time had tablets, and they were able to bring up, the lessons and the videos on the tablet, and then work from a workstation to do their work. What makes it different than other classes? It's fully project focused. I mentioned that the other night. Yeah, we will do obviously assignments and tutorials to help us get there, but it's about building the projects. Okay, we don't have to worry about hybrid classroom. By the way, we got the approval. This is online for the rest of the semester, so we're good to go. And we're going to leverage information systems to learn information systems. Basically, Access itself is an information system. Excel is an information system. Blackboard is an information system. We are going to use information systems. What we're trying to do here is show you what learning is going to be like in the future too. This class is going to be a lot like the classes you will take down the road. It won't be, we'll have people from all over the world chiming in to be educated. I actually took classes back in the 80s, believe it or not, for something called the National Technological University, where some of the best people in the world were teaching classes. The university didn't even exist. Okay, all the courses were online, and it was being run out of some little office in Atlanta somewhere. Okay, and we could get an honest to God ABET accredited degree taught by some of the greatest minds on the planet. What a deal. I personally think we got too many universities anyway, but there'll be another talk sometime. Anyway, what can you expect as far as how this is going to progress? Okay, I said this the other night. You will be afraid, okay, especially after you look at some of the projects students did in the past. You'll think, oh my God, I've never done anything like that. I know how much effort it takes to do things and little things in C. How can I possibly do that in 1 month? You're going to be amazed. Okay. We'll get into single subject databases, and you'll get frustrated sometimes, and I'll try to be, Aziz and I will try to be a cheerleader, and I'll get frustrated sometimes seeing your frustration, because I really don't think you should be. All right. But usually by the time we get to the second half of the semester, most of the students really have the cadence down correctly. They really understand what we're doing. They are anxious because they're starting to get in their head what they'd like to do for their project. We'll get into the part, the real heart of the classes, where I teach you about subject relationships and how you really do normalization of data. We'll talk about that in a minute, okay? And a lot of people really get into the class at that time. A lot of people enjoy this class because, as I said, it is kind of a design class. There's an artistic side of this. Aesthetics come into play. I want to see you make really nice user-friendly screens that look good. I want to see reports that are a work of art, that you would be proud to give to your manager and things like that. Okay, we're going to do things like that. That's going to be expected from you, and most of you will want to do that anyway. Okay, and then when you get done, you're going to feel not only relief, but you're going to feel accomplishment, satisfaction, like you have developed a skill. So I've said enough about why you're taking this. Okay. I just want to reiterate something I said several times last time. The critical thing for you is time. You have to give time to this class. Here's all the things that I thought about that you have to devote time to. Just put it in your head that you're going to do that. Okay. Don't procrastinate. Don't allow yourself to fall behind. Aziz and I were just saying, you know, we usually know after the first assignment who we're going to have problems with. Okay. If you don't do a good job structuring a table, you're going to have problems all semester. All right. So I always say, don't put it off. Get on it. As soon as I expose that assignment, look at it and start thinking about it. Watch the videos, try to understand how they map to the assignment, work the assignment, get it done. All right. So that's the frequently asked question parts. Now I'm going to get into the first lecture part. And again, I'm not doing this whole thing. In fact, I'm going to do an incredibly abbreviated version of this. Okay. But you'll want to look into this. And some of this does repeat some of what I just said. Where I want to go, I wanted to go to 11. An information system. If I have to give a formal definition, this is the kind of the cultural definition. An information system is a computer-based system of hardware and or software that synthesizes, calculates, transforms, stores, monitors, manages, tracks, and or transmits / delivers information for decision-making, insight, communication / collaboration, and or control / automation. Wow. Sounds like it solves world hunger. You know what? They do. All right. You guys have grown up in the information age. All right. And information systems are prevalent in your life. Most of you have a cell phone in your pocket right now or on your desk that has apps in it, that has utilities in it. Those are all information systems. The phone is an information system. You using the phone is an information system. Okay. They're all over the place. And they just keep making more and more and more of them. Okay. The cool thing is that we can, and we actually knock them out pretty quick now. In the old days, it would take massive number of people working for months and months on end to build these monolithic systems that were out of date before they even went into production. Now we can knock these things out like they're nothing. Apple comes out with a new iPhone every year just because they can, you know. But yeah, usually they're throwing new technology at you. Plus, they want you to consume it, right? They want you to give them their money. All right. And I'm always like 5 back because you know what? That's good enough for me, you know. But I see some of the cool features that they're putting. I go, man, I can't wait to 2 years from now when it's only $200 for that versus $2,000. All right. But if you're a company who's trying to survive, you may want to build those systems and be at the leading edge. And the technology has allowed us to do that quicker and safer and more foolproof than we've ever done it before. Okay. But it's not complete nirvana yet. Okay. We got a long way to go. And the other thing I want to impress on you is this. This is a little thing called a data flow diagram, okay, and this is just a segment of what would be a big data flow diagram. That what we're talking about is this thing here that processes input data and creates output data, but that output data then can become input data to other processes, and it may not only be one; it may go all over the place, and it may be at a different time and all that. And those processes themselves have controls over them or constraints, things like regulatory and needs or standards for data structures or something like that, you know, or standard types of data. You know, that could all influence how the system works. And then, of course, especially, how does this thing take care of the data that it has to store, you know, and how does it put it in there and how does it pull things out? You know, traditionally, this is what we think about when we think about an information system, the computational aspects. But it's also about the people that are using it. It's about the network it's running on. It's about the place it's being used. It's about the way that knowledge and data are being represented to it. That's all a part of the information system. It is something that the developer or the architect or whatever you want to call them, the engineer has to balance in order to make the thing well. He's got to address he or she have to address all these things when they build an information system. Yeah, the most conspicuous will be the thing they deliver. But I guarantee you, if you deliver them a piece of garbage, nobody's going to want to use it. If it isn't user friendly, no one's going to use it. If it doesn't work across different network chains or whatever else, it's not serving a purpose. If the data is garbage, the system is garbage. All right, so these are all the things that we're going to be very concerned about as we go through this class. We're going to be concerned about how we represent our data. We're going to be concerned about the logic that links the data to other data and the logic that's in our system. We're going to be concerned about how we could search through that data and how we could automate that search. We're going to be concerned about the dialogue that we have to have with the system, the user interface that we have to have with the system. We're going to be concerned about how we visualize that data so that when somebody asks us that says they need to make a decision about our data, they get to see it in a manner that helps them make that decision. We're going to worry about the flow of the whole thing. What is smart to do at any given time in this system? And we're going to worry about how that interfaces to other systems. That's all the things that we are going to learn about in balance here. And we're going to do that through what's called a relational method. Now, I might tell you, database systems are not the only ones that do this. Knowledge-based systems do the same thing. There are a lot of systems that have the same concept, information. They all fall under the umbrella of information systems. You're going to see it for databases. Toward the end of the class, I'm going to tell you about how it also applies to other kinds of information systems that are out there. And what was the last? I wanted to point out that there is a life cycle for information systems. We are mainly going to focus on what's called planning and architecting the system, designing the system, developing the system, and implementing the system. Okay, we're not going to worry too much about the sustaining, but I will talk about that a little bit. And of course, something that IEs should always do before they even start building an information system is understand the opportunity for it, assess that opportunity. That will sometimes highly constrain what you do on these other tasks. And then the other thing I always say, which is something that unfortunately industry hasn't even figured out it yet, is every information system has an endpoint. You know, you may evolve it into something else, into another information system, but usually at some point it's not serving much of a purpose and needs to be, you know, put to bed. You know, we make it obsolete. So anyway, there is a part in here that I call a brief history of information that I hope I get to do for you sometime. I'm not going to do it tonight, okay? But sometime if maybe we could do a special thing and anybody wants to join, they can. Maybe one of those lab nights, I can take maybe a 15-minute thing at the beginning of one of them. Again, we don't meet on lab nights, but we could if anybody wanted to. And I'll give you a little thing about the brief history of information, you know, how it's kind of evolved and how we got to where we are and all that. It's kind of interesting. I think you'd like it. Okay, so I'm going to go on to the next. Now, this is the second seminar. In this, I am really going to be thin, okay? And I'm going to go right here, okay? Going to go right to slide 18, okay? Watch the video, though, from last semester, okay? There is something I am supposed to do that ABET requires. It's telling you about data flow diagrams. They actually want me to teach you it. I'm not doing it because it's archaic, okay? I don't know, somebody at ABET needs to learn about information systems because the stuff they draw up for this class is just ridiculous, okay? Data flow diagrams only serve a good purpose if you're on still on a project that is kind of monolithic and you've got a lot going on and you need to make a blueprint. Otherwise, most of the tools that we use nowadays, you build as you design, and Access is built that way. That's called rapid prototyping. You build as you design, all right? And the cool thing is, if you get down away with the design and you realize there's something you didn't do quite right, it's usually easy to back up and fix it, you know? Or you can make the fix and it cascades through. It's actually does that because we leverage the ability of objects to send signals to other objects to even configure themselves. Again, you don't need to understand that right now. You just need to know that it's making your life a lot easier. Okay. All right. But I want to share this with you, and I'm going to blow up my screen a little bit here so you can see it better. And I do talk about this in the video from last semester. We're going to do it again because it's worth seeing twice. Okay. A long time ago, Dr. Masood, if you remember him, called me up and said, John, we're trying to build a database that links our faculty members to text and whatever references that they have. We want to have a virtual library, basically, but we need to know where things really are stored and all that. We want to build a database. I said, okay, that sounds good. Yeah, Trixie's doing it. I know none of you knew Trixie Lawrence. She was our OA at the time. Trixie was one of the best OAs I've ever met and one of the most exasperating OAs I've ever worked with. Okay. But anyway, I go out to see Trixie and this is what she had basically. Okay. Now I'm not giving you the real names of people and anything like that here. Okay. It's made up data, but it was like this. Okay. She had a spreadsheet. And I think you guys all know what that is, like Microsoft Excel. And she just had a table, basically, she called it. All right. Where she had information about team members, faculty members. It wasn't just faculty. It could have been teaching assistants, whatever else. And then references that they might have. So like you look at that, okay, you see Dr. Michael Edward, right? And they got information, they got a record in here for him. And he happens to own a textbook called Operations Research by Dunham and Lawn. And it's an OR book, and it could also be an LP book. And they gave it a classification as that it's a text, the book. And it was written in 1999. It's that version of it. It's got an LCN number on it. And he has one copy of it. That's cool. Oh, he also has Sham's calculus. So we'll put his information in here again and write this stuff about Sham's. Oh, he also has, you know what? He had a lot more than 3. I'll tell you that much. Okay. He had thousands. Then they went on and did the next one. And you got Barack Obama here. And Barack Obama, oh, he also had that operations research book. So I'm going to list that one again for him. And I think you get where I'm going here. Isn't this ridiculous? Isn't this redundant? Putting all this data in here over and over and over and over and over. This is what's called a many-to-many relationship. A team member can own many references, and a particular type of reference can be owned by many different team members. I'm not talking about the specific reference. I'm talking about the book Operations Research. This guy's got a copy. This guy's got a copy. This guy's got a copy. All right. Wouldn't it be better if I could put him in here once and say, point to all the ones that belong to him? And conversely, put this in here and I point to all the ones in it. I mean, I only have to point once, obviously. I could derive it the other way too then. All right. That's called a many-to-many relationship. That's what we do with relational databases. We normalize the data. This is non-normal data. I want to call it unnormal data. It is unnormal, but it's non-normal data. It's not normalized. We are mainly going to, that's what this semester is going to be about, is taking data that is really bad and normalize it to make it more efficient. That's what we do. We optimize things, right? We're going to try to make our databases as efficient as possible by never repeating data, number one, by associating data, but associating it at a single point. All these guys have a social security number. That's unique to each one of them. We could relate each reference instead of to the whole record, just to that one field. Now, I'm going to tell you, there's a better way of doing that. And I'll talk about that next Tuesday when we talk about the keys of the database. Okay, we'll learn about the primary key, the first two, the two big keys, the primary key and the alternate key. That's the first thing we'll do. And you can read ahead on that. You have the workbook segment for lesson 1 that's already posted on Blackboard. All right. There's other problems in here too. Okay. For one, if I look here, where was it again? I highlight them so I would know them. Okay. Let's see, where were they again? Yeah, this one pops up over and over. They got that one in there several different places. This one's in some. There was one here where they got the authors reversed. I can't remember where that is. One where it's Nixon and then Lincoln, another one where it's Lincoln then Nixon. All right. You got this one right here where it had 3 authors so that she put 2 in the same field. You think that's easy to search on? Well, if it's something this big, maybe you could do it in Excel. What if this was a database for the IRS? Don't you think they'd have a lot of records over a lot of different subjects? Don't you think it'd be very difficult, and that they would want to make sure that things are structured really well? In the case of authors, am I limited to 2? No, I just showed you. You can have 3. I can have 4. I can have as many as I want, right? Does she keep putting a field in there when she suddenly has one that's got more than what she had before? I've got 3 subjects. Could I have more than them? Sure. Could they be constrained? In other words, they could take on certain values. You bet. Here, type text. I got text, guide, magazine. Maybe I want to limit that field. Maybe I want to have like a drop down where I can pick from it. Maybe on one where it could be maybe in one of these where it's multiple, I have one field where I could pick multiple on that one. What about this thing where copies? It's a number, right? Well, I could say only numbers go in there. In fact, I can even have a rule that says it has to be greater than 0, or it can't be negative. Let's say that, because I'll never have a negative number of copies of the thing, right? Maybe I have an upper limit, Maybe I never have more than 200 copies of something. Who knows? Maybe when it's a text, it changes what the upper limit is versus what a guide is. Okay, we are going to learn how to do all those kind of things so that the end user could be really stupid and not cause us trouble. Okay, that's blunt, I know, but that's the truth. Okay, give somebody a piece of software and allow them to do anything, and they will do anything with it. And that's when the thing crashes. And now people are calling you in the middle of the night saying, your system sucks. Okay. We're not going to have that happen to us, because we're going to take the time to make sure that all this kind of stuff works. And again, you're going to be pretty amazed how easy it is to do that. Look at this, the phone numbers. They all have the 3-digit prefix dash 4 digits after it. Okay. You know what? I could put a template in that field so that they couldn't do anything else except enter 3 and then 4. All right. I can make it so it's only numbers that they enter. We're going to actually start learning about that. Not next time, but the class after that, how to build what's called an input mask for our fields. You see, a lot of these sometimes have nothing in them. Blank things are bad sometimes. They do still take up space. We're going to learn that doesn't have to be that way in a database. All right. We could deal with null values. Here you got something where they got a text and they don't have anybody assigned to it. Okay. We could keep that from happening. We could say that, hey, if there's a text in here, there has to be somebody who owns it. Otherwise, it doesn't make sense to have one. All those kind of things come into play. We could have, say, a professor who has multiple phone numbers. Again, rather than putting fields in there might be something about the phone we need to keep track of, like whether it's a cell phone or a landline, or there's certain times a day, or he won't answer it, or there's a message thing on it that, those are about the phone belonging to that professor. So there's really 2 subjects that have to play together. The professor could have many phones, but a phone can only be owned by one professor. That's a one-to-many situation. And we'll even see one-to-ones, okay? Almost everything we do will be based off of either a one-to-one, one-to-many, or a many-to-many. Everything we do will be one of those master types of relationships, but there's a lot of different variations on that we'll cover in the class. Any questions about that? Because I'm going to go on to the end here then, if that's good. Are we good? Aziz, are we good? Aziz?
Yes, we are.
Okay, no chat questions?
No.
Okay, good. Let me zip ahead here, okay? When I talk about relationships, one of the things that Access is going to do is going to allow us to set what's called referential integrity on our relationships. It's one of the things that allows you to make sure that everything exists in your database for a purpose, okay? I just used the example that a professor could have many phones. If the professor left the university and I deleted his record, does it make sense for me to hold on to the phones that he had? Probably not. So when that professor's record goes away, then I want records that are over in a table that's in a relationship to it to go away. Now, I may have some situations where I don't, maybe it's you. Okay. You have a transcript. Okay. You've taken many classes where you've gotten grades. You leave the university system. We remove you as a student. Does that mean we want to get rid of the record of your grades? No, that's your transcript. Why would we do that? Now that's a pretty bad example, because what we would really do is we'd have a field in your thing saying whether or not you're an active student and keep you forever, really. Okay, we wouldn't clear you out, unless it was 100 years down the road and we need space in our database, and then we might do it. And then we might not care if we get rid of your transcript either, but we may decide to keep your transcript. I didn't mean to go down that road too much. We'll talk more and more about relationships and what they mean as we go along. But Access is going to give us the ability to graphically, to some extent, graphically specify how relationships work. And you can see in here, like, for instance, I've got member, which could be the faculty member, and I have references. Okay. And we said it's a many-to-many relationship. The way we do that is we do something that's called we build a table that's intermediate to it. We're bringing records from this table and records from this table together in a record that we call a junction record. This is a junction table. This is a many-to-many, but we have one-to-manys in here. We have different flavors of one-to-manys. One of the first ones we're going to learn is the category relationship, which is one of the most important ones that we'll actually learn in lesson 2. And they'll give you it's an easy one, and it gives you a really interesting exposure to relationships to start out with before I give you the hard ones, and then they'll make a little bit more sense to you. And there's even a one-to-one here that they split out some of the members' password information from the regular table simply because it's sensitive and they want to take care of it by itself. Maybe it's in a behind a firewall or something like that. So they want it still related to the original members record, but they want it handled separately. You could do things like that. Okay. Now, one thing I want to be careful of, this is a very old diagram. This was before I incorporated what's called the naming conventions into the class. These tables and these fields, this represents the table. This represents the fields of the table. They would have a naming convention, and you will use those naming conventions in this class. And I will start exposing you to those next week again. All right. So I'm going to get out of that and that. And I am going to go over to Blackboard. Hopefully it did not log me off. No, it didn't. Okay. And I'm not going to give you a complete tour. I'm going to give you things in segments, but I think a lot of you have already looked around and figured out, the announcements were there. By the way, I have to point out there's a COVID statement in here. Please look at it. I'm not asking you to sign anything or anything like that. I mentioned about the Zoom meetings that there was a mistake made on the Thursday night meetings, and I will fix that. When I do, hopefully I won't have to send you a new link. Okay, you'll just use the link from Tuesday all the time. But if I do, I will send that to you. So be watching your email for an announcement just in case. And when I get that fixed, I will fix up what's under the part that says Zoom meetings here. They'll just be Tuesday night ones, Google and Outlook in here. Okay, the announcements will always be here so you get to them. Where I want to go now is the information section. Again, I sent you an email about this. I hope you had a chance to look at it. That's sort of the frequently asked questions thing is that I just did tonight. My VITA is there too. Our syllabus and our class schedule is there. You will not see this one. It's the software. I'll expose that one at the end. You're seeing this from my view. Okay. My view, I get to see everything. You don't. Okay. You only get to see the things that as I expose them. Okay. But at some point I will expose the baseline object library, and it will be the more up-to-date one. This is 2019. We have one for 2021 that we'll be putting out there. But the two big ones for you to know here are the references. The reason the references are here, yeah, they do tend to align with lessons, but usually when they're introduced, they're good for all the lessons beyond that. Okay. There is no real order here. Some of them I try to give codes like the videos are RV, because they're videos, and the access naming conventions are RA, and the course naming conventions, because it's really about the course and the workbook and all that. I made that R0. Okay. I'm going to open that one in particular right now. If you go in there, when you open up the PDF files that start with an L, okay, the PDFs, not the videos, the PDFs, those are parts of the workbook, okay? So you'll have an L01. There is no L00. That's just these seminars that I did. But L01, L02, all the way down to L07 are part of the workbook, okay? In that workbook, I color code things a lot, okay? And if you come down here, you'll see what those color codes mean, all right? Here's the conventions that I use in the workbook. Sometimes I make things bold. That has meaning. Sometimes it has bold in a different color. Sometimes they're italicized. That all has meaning. It won't take you very long to pick this up, okay? Most students just get this really quick, okay? And then the other thing I want to point out is I give you a lot of files. I tend to prefix the files with a letter, sometimes a combination of letters. That means something, all right? All right, the seminars were all, the PDFs for that were prefixed with S. The lessons are prefixed with L. Some of the videos for the lessons are too, okay? They are prefixed L, okay? In the workbook, the sections have letters, okay? F's are fundamentals. That's like, this is what this is about, okay? Then I won't call it the theory behind it, but it's the fundamental things that you want to understand about the thing. E are examples, T are the tutorials, and that's both T, a section in the workbook that has the step-by-steps for the tutorials, and then the files that are for the tutorials start with T, okay? And then there's this thing called 5T, and I think you get the rest of these assignments. The graduate thing does not come in play in this class. Don't worry about that. Final exam starts with Z. The references all start with R. V for the videos, I for image files, and O for optional files. There aren't too many of those, okay?
We
yeah.
have Rashad Khalili. He has a question.
Go ahead.
Hello. If you remember, I emailed you on Tuesday and you sent me a link to join, but that link that I joined, it just took me to a Zoom meeting that it was just me there. So I tried to use the one that you just announced today.
Yeah.
And I could not join until like 5 times. I was trying.
I don't know. It worked for everybody else, obviously. So for the last class, I recorded it, okay? And I sent that an email out with the link to the recording, so you could still see that, okay? How did you get on right now?
Okay, the link that you put the last announcement, I joined from there by clicking on it, but it wasn't working till like it would take me to the section that is say like join or something like that. And then it wasn't opening it, although I was just like tabbing on it.
I don't know. So, I know you may be connecting to the wrong network for some reason. If that doesn't work, try connecting from the web. Okay, there's an option on there to connect from your browser. Try that.
Okay.
Okay. Okay. Yeah, guys, I don't want these lessons to become a help desk. If you're having problems with stuff like that, that's stuff we take care of after class, not while I'm teaching. Okay. All right.
Okay. Sorry.
All right. That's okay. You didn't know, you weren't here last time. All right. So where did I want to go next? Oh, I wanted to go back out and lost my train of thought. Sorry about that. And this is the problem I have with all this. I can't get back when it's like this. How am I going to get the browser? Okay, I could do this. Okay. I had to minimize the browser so I could get back to it. All right, let's try that. Okay. The other one I wanted to show you is, well, first off, I'm going to go into the course material. And you'll see I've got all the lessons here right now. You just have lesson 0 and lesson 1. I'm going to open up the one for lesson 1 right now. And I will talk to you about the things that are underneath the lessons the next time I do this. Okay. Right now I want to show you, for example, this is the workbook section for lesson 1. I'm going to open up that right now. So you could, because this is the part I really want to show you. Okay. In the workbook, there are different sections. Okay. You'll have this scene at the front that's kind of the index to the whole thing. Don't worry about it. You'll usually have a section that captures the stuff that's in reference RA that applies to this lesson. So these are the naming conventions that apply to the stuff that you're learning in this lesson. RA itself has all of them in there, okay? But this is the one that for this first lesson, you're going to learn about tables, keys, and fields. You've got them all here, okay? Again, they are color-coded. Look that up. The green ones are the ones we tend to use a lot. The red ones are the ones we tend not to use very much. The ones that are kind of a yellow color here, once in a while we'll use them, you know, or you may use them, okay? But I probably won't use them very much in this class. Again, you'll get a section called Fundamental. It's what's called a document map where you have topics, and in this framework, you'll see what those topics are about, okay? And I have little notes on here that are color-coded. Again, colors mean something, look it up, all right? You get down here a little bit further past that part, and then you'll sometimes see an example of what we're about to do. And then finally, you get down to the tutorial, okay? And again, there's a video for each one of these tutorials, and almost all of them I will do when I do the lesson with you, okay? Now, again, the first few we'll do together, okay? And then after that, you'll be watching pre-recorded videos. You don't have to do them along with me, and I will not do the whole thing. Instead, when I do the lesson, what I want to do is point out things that I think are incredibly important that I hope you gleaned out of doing it yourself. But again, they will be a lot like the assignments then. The thing I want to show you here yet before I leave this, at the very bottom, there's a section called the 5 T's, okay? And that stands for tips, tricks, traps, truths, and twists. These are things about what you just learned in the lesson. It's kind of a summary, categorized by whether it's a tip or whether it's a kind of a trick to doing things, or if it's something to be aware of, be careful of, it's a trap, or if it's a honest to God, this has to be, it's fundamental to building a database, it's truth. A twist is access. If you pick up most access documentation, it'll tell you to do it one way. And I'm telling you, that's not the best way to do it. There's a better way to do it. In the lesson, you're always going to be doing it the way I do it, okay, and the way you ought to do it, okay? You're not going to be doing it another way in access. And that's why I told you, if you already know access, I'm asking you to kind of forget it, okay, and act like you never did it before. Don't go off script, okay? It will just get you into a lot of trouble as we go along, all right? So hopefully that's a good explanation about all that for you. And now I want to go back again. I'm going to have to pull this down again. I want to go back to, and I'm finishing it up here really quick, okay? Because the last one I want you to start looking at before we meet next time is this one that's called RA. Now, RV, again, will have a list of all the videos and all the links to the videos for the class, but I have not exposed them all. The Mastering Access videos, they're all there. They're all out there. I don't own them, so I just have a link there. But you see them there, and you will go through them, and you can do them as part of your lab, or you can do them ahead of time. It's up to you guys, okay? All right. The ones that have to do with tutorials and lessons, I expose them as I think you need them, all right? Right now, there's a few ahead, but not all of them, all right? So if you try to click some that are further down the list, I don't have them open to the public. I don't have them open to you, I should say, okay? I have them set private, okay? As I go along, I'll expose those just as I expose things on Blackboard. And then you'll be able to have added, okay? But this RA access naming conventions is going to be incredibly critical to this class, all right? And I'm not going to spend time teaching it in great depth. You're going to pick it up from seeing me doing it, from seeing me do it in the unnarrated tutorials, from seeing examples that I give you. I mean, I'm going to give you a lot. Now, again, I do know that even after I give you those, some people will still make some flubs. Again, if you tried, we're not going to go crazy on you initially in class, but it is going to be important as you go along that you really do this right, all right? I'm telling you the mistake a lot of people make. They put a space in field names. Don't ever do that, okay? Access doesn't know where the field name begins and where it ends when you put a space in it, all right? The reason we do this, I'm going to tell you again, is because so many common field names that you would use in your projects or we would use in assignments are actually reserved words in Access. And when you do that, if you don't give it the prefix and let it know what table it came from, Access gets confused and suddenly something that looks like it should be working right doesn't work right. The other thing, you will find sometimes that you need the same field name in different tables. Using the naming convention actually identifies where that field resides so that you know you're working on. It will help you in debugging your database. It will help you, especially later on when we do macros, because you have the same field name and you haven't used some kind of identifier to say where it is. Access just does the best guess it can, and it may use the wrong one, and it could change data on you that you don't intend to change. All right. And then you'll notice that I use this 3-letter prefix on tables, on fields, and for other things. Okay, but mainly for tables and fields. That's mainly where we'll use it. And on anything else that we'll reference, and I don't know, you don't know what that means, but later on, you'll see references. You'll understand why we do it there, okay? It's usually references for controls that we might once in a while have to name and use a naming convention, all right? But for tables and fields, we have to use them, and you have to do it this way, and you have to give it that prefix, okay? The reason for that is all the objects I give you know about each other, but they know it through this naming convention. If you use something else, suddenly the objects don't work together. All right. So it's a little bit extra typing, but believe me, it will save you gobs of grief as you go along. So please look at this ahead of time. Again, it is kind of color coded, where the green stuff are the things that we will do it, and we will use it a lot. The yellow ones we won't use very often. When I say yellow, I mean the pale yellow one. Okay, I know I got some that are really highlighted here in yellow. Okay, I'll explain that in a second. And the ones in a pale red, we probably won't use it. The stuff in bright red, avoid it. Okay, I've got it listed there because if you ever, after this, people use this outside the class after they get done. Truthfully, this has been published. Okay, Microsoft started it. I made it work. Okay, and I've actually had presentations at conferences where this is all I did, and professors have taken it and reused it in their classes, and all I ever get is, man, that was a godsend, you know. So anyway, it's probably one of the great things I've done in my life is come up with these naming conventions for Access. And truth is, anybody with this system development really ought to use naming conventions. It helps with, again, with debugging and maintenance and anything at the very least, but also helps with construction. So anyway, that's it. Any questions?
Real quick, what would you say you want us to have looked at and be done before like next session?
I'd like you to look at that video link I sent last time. All right.
Okay.
I'd like you to look through lesson 1.
Okay.
Okay.
Awesome.
All right. If you want to start looking at the tutorial videos for lesson 1, did I expose those yet? Maybe I didn't. Okay. In fact, I won't. Well, yeah, I will, because we're actually going to do 2 tutorials. They're little ones, you know, we get through them pretty quick, you know, and I will ask you to do them on your own. Yeah, I will. If I haven't done that already, I'll expose the first tutorial videos if you want to look at that ahead of time. You know, this is one of the, usually you do the lab, you do the tutorials, and then we come in and we do it together. You know, you watch the videos and then we come in and do it together. All right. But to start out, there's these 2 little tutorials where we don't have a lab before them. You know, yeah, please watch those. I think it's worthwhile. I think one is like 5 minutes and the other one's 6 minutes. It's not very big, you know. Of course, my explanation will be a lot longer than that, you know, because you won't know really what you'll see the mechanics, but you won't understand why we're doing it. I'll give you a little bit more background on that, okay? But especially look at lesson 1, watch that, the seminar 2, the parts that I didn't do. And oh yeah, by the way, in that video also, something else I wasn't able to do tonight that I just didn't have time. I actually do 2 demonstrations of projects that students did in previous semester, just to give you an idea of what we're aiming at here, okay? And if I have time next time, I may do another one for you, okay? I may run another one of the student projects, okay? Everybody good?
Nice.
All right. If there's no more questions, I'll see you next week.
Professor, I had a question.
Oh, by the
I
way,
was one of the.
really quick, before all you leave, please watch your email. Okay. Again, things will happen after class where I should have said this, or a student will remind me of something, or something pops up. I use email, the announcements, to communicate with you guys a lot. Okay. Please be on the lookout for that. Especially be on the lookout in case I do have to change the Zoom link for this class. Okay. All right. Thanks. Now, okay. The question.
Professor, I was one of the waitlisted students and you asked me to do a survey, but I read that the survey was sent out in an email before I was in this class. So did you still want me to fill it out or?
No.
Okay.
No. That was intended for the people that normally got through normal registration. They basically had your fate in their hands, is what it amounted to. So, and like I said, it seems like they did I don't want to say did the right thing, but they did a good thing. We have 2 more students tonight than we did last time. That tells me they let some people from the wait list in, as yourself. I think we had 3 on the wait list, so I'm expecting 1 more yet if they haven't gotten in yet. They weren't in the visual roster, whoever they are, but Z said he checked and he said there is 1 more on the wait list. I had 3 more ask if they could get in, and I hate to say it, I feel bad, but if you didn't take the time to even get on the wait list, what can I do, So anyway, are we okay?
Yeah, thank you, sir.
Okay. Anything else? Sean?
Yeah, I have 1 more question.
Okay, I thought Sean was raising it. Sean, were you asking something? Sean Trask? No? Okay. Who else?
Yeah, on the RV course schedule,
Uh-huh.
can we just go down that line and watch every video for lesson 1, and that will be this week's assignments?
Yeah, we actually for the lesson 1 videos and that you can do that in lab if you want. That's where I expected you to do that in lab, and tutorial 0102. Okay, but Alan, you want to get it? You can look ahead. They're available. Okay. The Mastering Access videos all of them are available all the time. If you're asking me, do you have to? No. Do I want you to? Sure. I always want people to get ahead. Feel free.
Okay. So we just need to watch those orange videos then.
Yeah.
Okay. Thank you.
If you stay on, Alan. Okay. I think let me make sure I actually posted them the way they needed to be posted. I usually do. Okay. If I go on course materials, I look under lesson 1. I'm going to go in as if I'm a student here. Okay. You have lesson 1, the key stuff. You have lesson 1, 2, which is about subject tables. So those are the, let me think here. Lesson 0, it's lesson 01-01 is the video that I did last year that has me demonstrating how to do the tutorial 0101A and 0101B, okay, which is about 0101A is about keys and B is about the data sheet and how we actually populate data, okay? Very simple. All right. If you want to look at those ahead of time, that's basically what I'm going to cover next time we get together. I'm going to do those 2. All right. Read L01, read this, and then in the lab part of it, you are free to look at all these videos that you want to. Okay. The Mastering Access videos are right here, and then the tutorial videos. And again, I'm going to be doing those first 2. If you want to look at all 3, feel free, but you're going to get a lab next Thursday. Isn't that right, Aziz? Yeah. Next Thursday is lab 1.
Yes.
And so in lab, if you don't watch them ahead of time, you watch them in lab 1. Okay. That's basically it. Okay. But if you want to watch them ahead of time, you can feel free. I would definitely recommend that 102. If you're going to let anything go, wait on that one. Do that one in the lab. All right. Tutorial 0102. All right.
Okay. So that Thursday, that will be a work day for lab 1.
Yes. That's a work night for lab 1.
Okay. Thank you.
Does that make sense, Alan?
Yes, that makes sense.
Okay.
Yeah, thank you.
So do we watch the videos and replicate it and turn that in, or is
No,
it just to
no,
watch it?
no. You don't turn in the tutorials. Okay. I mean, I've offered in the past, if people are really concerned that am I doing this right or not, you could turn them in. You could just email them to Aziz or myself, and we'll take a glance and we'll just say, yeah, you're okay. Or if you're really missing it, we'll say, well, you better go back and look at it again. You missed this, but again, I rarely have that situation where somebody feels that they need to have the tutorials verified. Okay. And Z's, don't let me forget to tell them this next week. Okay. For the tutorials also, there's usually a compiled version of it. Now on T01, A and B, there isn't. Okay. We're just going to work those. Okay. Because again, they're no big deal. Okay. But on T02, where we're actually going to build our first table, there's a compiled version of it. What a compiled version is, it allows you to bring it up in datasheet mode and see how it works, for entering data and managing data. But you won't be able to go in and see the design of it. All right. That's what you'll be doing in the tutorial itself. And when you get done, your thing should work the same way as my compiled version does. All right. So you do get something to give yourself a feel that I did it right by looking at those. And again, I'll explain that again next time we're together. But if you look at, and by the way, there's a compiled version, it's 32 or 64, depending on the bit size of your computer. If you're using a 64-bit computer, you want to run the one that says compiled 64. Otherwise, 32-bit, you run compiled 32. But they're both the same thing. Okay, there's no difference between them. They've just been compiled under different operating systems, basically. Okay. Boy, you guys got a lot of information that I'm going to have to repeat next week. So, all right. Otherwise, thanks very much, and I will see you next Tuesday. Have a good weekend.
Thanks.
Thank you.
Bye-bye.
Thank you.
Bye-bye.
Bye.
Thank you.
Thanks for staying on too. Appreciate it. Stop sharing and stop